Now, this is the discovery kit that we are going to use. So it is going to look like this, and this is the STM32F411E discovery board. Let us go through the different features of this board. If you have by any chance STM32F407 also, it should be compatible, and I don't think you will need to write any except for the peripherals. I do not think, but then the course is going to be done on the STM32411 VE MCU. Now we'll have a look at the MCU datasheet. Before we look at the MCU datasheet, let us go through the main characteristics of this particular board. So it has a STM32F411 VET6 microcontroller featuring 512 KB of flash and 128 KB of RAM in a LQFP 100 package. So it has got an onboard ST-Link V2 with selection mode switch to use the kit as a standalone ST-Link V2 with SWD connector for programming and debugging. So you can use this as a separate debugger also. It's got a board power supply through USB bus or from an external 5V supply. External application power supply of 3V and 5V. L3G20 ST MEMS motion sensor. It has got a motion sensor. It's got a 3-axis digital output gyroscope. It has got LSM303DL8C ST MEMS system in package featuring a 3D digital linear acceleration sensor and a 3D digital magnetic sensor. So all of this can be programmed and used. You have a MP4 5D-T02 ST MEMS audio sensor also, which is omnidirectional digital microphone. And you have a CS4 3L22 audio DAC with integrated Class D speaker driver. You've got 8 LEDs, LED 1 red green for USB communication, LED 2 red for 3.3 volt power on, 4 user LEDs, that is orange, green, red and blue, which we will be using a lot in our course, and 2 USB OTG LEDs, that is green, LD7 is green VBus and LD8 is red for overcurrent. 2 push buttons, user and reset. We'll be using these push buttons also for demonstrating GPIO and interrupts. USB OTG with micro AB connector. Extension header for LQFP IOs for a quick connection to the prototyping board and easy probing. So you have extension headers or IOs, which are these pins. Now let us look into the data sheet for the discovery board, and so that when you are actually using all these components, different components on the board, you'll have a better idea as to where they are and what to do with them. So let's go back to the PDFs, and this is the discovery user manual UM1842. Now this is the discovery board that we just saw, and when you procure the board, it is going to look like this. And so this discovery kit helps you to discover the entry level of the STM32F4 series to develop your applications. It's based on an STM32F411 VET6 microcontroller and includes the ST-Link V2 embedded debug tool. It has all of that, so which we saw: accelerometer, magnetometer, and LEDs, push buttons, and so on. So this is the table of contents. Going down, you have a list of figures, some conventions. Then so when you procure the board, first when you power on the board, you will have a program running which makes use of the accelerometer, and you will have whichever direction you tilt the board, you will have that particular LED blinking faster and so on. So you'll know that your board is working. So we'll not go through all of this, getting started, system requirements and so on. So we'll be using, and of course the development toolchain that we'll be using is a GCC based IDE. So we'll be using the Cube IDE from ST only, and we'll be running code. So these are the features which we actually spoke of just now. But let us look at the hardware layout. The hardware layout of our board. So this board has the embedded ST-Link with a mini USB connector on one end. You have the processor, and you have these IOs utilized. So you have the headers for the IOs, and then you have the reset circuitry here. You have a user button connected to the IOs. Then you have all the MEMS sensors, accelerometers, and so on. your sound subsystem is here, and other subsystems are here. So this is what the board looks like. That's a block diagram of the board. So going forward, if you look at your board, okay, and if you try to identify the different parts of the board, this is the diagram that you should refer. You have the top layout, which has the LED1, that is a green LED, that is communication LED. That's a red LED, that is a power LED. Okay. ST-Link discovery selector, these are some jumpers. Since we'll be using this one to debug this controller, you just leave the jumpers alone, leave them at their place. We will not disturb them. You have JP2 for measurement. Okay, so it's JP2 is for current measurement, and then you have 5-volt power supply, 3-volt power supply output. Okay, SB2 is the it's a reset. LD3 is the orange LED. Okay, it's a B2 reset orange LED, P2 reset button. So you have a reset B2 reset button. LD5 is a red LED. Okay, LD8 is a red LED for a different purpose here. This is for the USB. LD7 is a green LED. This is a blue LED, that is the user LEDs. Okay, this is the user button. Okay, this is the controller. So these are the different parts of the discovery board. So when you have to find out which part is where, then you have to refer to this diagram. This is the underside of the board, again describing the different parts. Then you have the embedded ST-Link, which is the debugging tool that the discovery board has. So this is a separate processor which has got the debugging utility flashed on it. So that's again an ST controller only. So and that is used for debugging. So that acts as a SWD debugger. Okay. So again, you can use that to program debug the STM32F411 on board. Okay, so that's pretty simple, straightforward. You need to keep the jumpers on here to do that. And then these are the debug connectors. Talk about the different debug connectors, power supply and power selection. Okay. So we'll just leave it at that, where we'll draw the power from the USB. But just be careful when you connect if you are planning to connect an oscilloscope to the I/O pins, you have to be a bit careful. So there are certain things that you need to be careful about before you connect a oscilloscope. We'll not be using any oscilloscope here in our course, but then if you are planning to check your board and you want to test some waveforms from the I/O port, then you need to be a bit careful. So these are power supply details. And you have the LEDs. So LEDs are these are user LEDs, and the user LEDs are in port D, 12, 13, 14, 15. This is a comment that I have put. This was not there in the user manual, of course. So this is something I have put for my reference. So, and we'll be using this port. We'll be configuring this port and using these LEDs. So user LEDs are in port D, 12, 13, 14, 15, and then the push button is in port A0. So yeah, this is a comment put by me. This was not there in the datasheet, or rather the user manual. Okay, and then you have the board has audio capability, and then you have it talks about the e-compass, the gyroscope. So it gives you an overview of. But then again, if you really want to know about this controller or this processor, L3GD20, then you have to go to that particular processor datasheet to know more about it. So like you can communicate with the processor through I2C SPI, and the I2C SPI, it's actually connected to our processor. But then again, if you wanted to know about controlling this, then you have to go to the particular datasheet for this MEMS L3GD20 chip, and then you have to check it out. Same applies here. So you want to use the compass, you have to go into the data sheet of that particular controller and then look into that. Then again, you have the jumper 2, which is where you can allows the labeled LED allows the current consumption to be measured by removing a jumper and connecting an ammeter. So you can actually do current measurement here. So if you have an ammeter and you connect it there, and mind it, when you are connecting an ammeter, current is flowing through your ammeter. So if you don't connect the ammeter, then this is an open circuit. Your STM32F411 is not going to be powered. So be careful about that. It is not voltage measurement, it is current measurement. So current measurement would mean, in this case, these terminals are open, so an ammeter must be connected to measure the current. If there is no ammeter, this is not powered. Okay. Then you have the oscillator, clock supply, the MCO from ST-Link, the frequency cannot be changed. So all of this is fine, and it gives you more information about the board. Then it gives you boot configuration, solder bridge information, and it talks about the pins, all the pin numbers, PA14. So it's all marked there on the board, what pins stand, what are the pin numbers, and then you have to come here and you have to check out what that pin stands for. And another, like I was saying, another important part of this document, user manual, is the mechanical drawings. So it talks about the layout, the mechanical drawing, the dimensions of the board, and then it has your schematics. Very important if you are whether using the onboard chips, okay, and then you want to know what is connected where and how. The schematics are very important. For example, if you say you are using you want to use the push button, okay, and the push button is let's find out the push button here. Okay? This is the MCU diagram, that is the main controller, and how all the all the pins are utilized. These are the pins that output ports, and this is what is going into the oscillator. So we'll be using this oscillator for configuring our controller, okay, so and so on. So this one again, this is the we'll see the debug unit also closely, and then you have the audio unit, where you have the CS43L22 chip, okay, which is the audio unit. Now, like I was saying, let's try to find out where this is the USB unit, okay, this is the hardware for the USB, and this is the peripherals. Now suppose you need to know this button. So the button can be active high or active low in the case, in our case. So this is the wake up button and the reset button. That's a blue button and the black button that you will see on the board. So this is the hardware diagram for the blue button, that is the user and the wake up button, and this is active high. And then you have the reset button, which grounds the controller when you press it. Okay. So you can say that the button is an active low. So thus you will see a lot of information about this is the hardware, and this is one extremely important part of the controller. Now let's try to see where I just missed it maybe. Let's try to see where the debug unit is. This is the audio unit. Let's see where you can find the debug unit. So this is the ST-Link debug unit, okay. This is SWD only, so it doesn't support JTAG. So this is the main controller here, and if you want to see what that controller is, you'll see that it is an STM32F411 So it's an STM controller only, and it's an STM it's an ARM Cortex-M only, which is doing the debugging job for you. So when you connect the USB to the board, it supplies power to the board, and it also acts as the interface too. So this one on one end it does the debug, and on the other end it connects to the USB and communicates with the computer. So this is the bridge, basically. It's a debugger. It's a bridge between the UI debug side of the board. That is the debugging signals which have to be fed to our main controller STM32F, and the other end of the board is connected to USB, so that those signals are converted to USB and fed into the computer. And then we'll have a GDB server sitting on the side of the computer, which is going to take in those signals and control the board. That is, it is going to put the board into debug and get into a debug session. Of course, these two, even if they are shown here, this is useless. It's not this UART will not be using this UART. That is, ideally in some boards, even in the Nucleo boards for STM, the UART can also be accessed through the USB port. But in our case, for this controller, we'll have to have a separate TTL to USB converter, and then we can access the UART. So that's in brief what the discovery user manual is all about. So this is just to give you an introduction of what the discovery user manual is and what it can do for you. Have a look at the manual, go through them, all the manuals that you downloaded, and it is interesting. It is you get a lot of information, but the information can be confusing at times because there is so much to learn, so much information to digest. But then we'll take it slowly, and we'll unfold the course gradually, so that by the end you should be quite comfortable with whatever I intend to convey to you.